Welcome to the YouTube channel, Mr. Rafa Online Tuitions. Please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions, and click on that notification button so that whenever I upload the video of this nature, you'll be able to watch and learn. Join me as we crack down the codes of mathematics paper 2 GCE 2024 final examinations. Question 3. Question 3A. X plus 2 over x plus 2 minus 5 over 3x minus 1 as a single fraction in its simplest form. So the first thing in this question, it is to find the lowest common denominator. So the lowest common denominators are x plus 2, 3x minus 1. So that is the lowest common denominator. So x plus 2, 3x minus 1. So these are the lowest common denominators. Then I'll begin to divide x plus 2 into x plus 2, 3x minus 1. So x plus 2 and x plus 2 will go. We will remain with 3x minus 1 times 2. So it will be 2 times 3x minus 1 minus 5, 3x minus 1 into x plus 2, 3x minus 1. So this one and this one goes. We remain with x plus 2. So x plus 2. So from there, I'll break the brackets. 2 times 3x, that is 6x. 2 times negative 1, that is negative 2. Negative 5, remember you need to treat this one as a negative. Okay, so negative 5 times x, it is negative 5x. Negative 5 times positive 2, the answer is negative 10 over x plus 2, 3x minus 1 as our denominators. Then from there, we are going to correct the like terms. What are the like terms? Those terms with same letters with same powers. So now this is 6x and 5x. These two are like terms. So I'll say 6x minus. So you maintain the sign because there is no equal sign here. So you maintain the sign. So this sign is not going to change because it is not crossing any equal sign. So you maintain the sign, which is 5x minus 2 minus 10 over x plus 2, 3x minus 1. So there we say 6x minus 5, 6x minus 5, that is x. Negative 2 minus 10, that is negative 12 over x plus 2, 3x minus 1. So that is the final answer. Part B, in the following diagram, vector OA is equal to scalar A, vector OB is equal to scalar B, and AX to AB is equal to 2 to 3. So that is the diagram that we have. Part 1, express in terms of scalar A and or scalar B, vector AB. So vector AB is equal to, so we want vector AB. So in this case, we are going to move triangular. Okay, we are going to move triangular. So vector AB is equal to, I'll go back on A. Okay, then I'll use the other root. So this root, we don't have AY, we don't have YB. Now we have AO and OB. So I'll use this root. So vector AB is equal to A AO plus OB. Okay, so vector AB is equal to AO plus OB. So vector AB is equal to vector AO, it is going to be negative. The reason is very simple. It is because we are going against the direction of the vector. So it is AO. How do we know that we are going against the direction? This arrow, it shows the direction of a vector. So now we are going AO against. So this scalar, it is going to be negative scalar A. Negative scalar A plus vector OB. OB is going to be positive. It is scalar B. So from there, I'll say vector AB is equal to the positive scalar. It will come this side. Then the negative goes inside. So this is vector AB. Part B, vector XB. So vector XB, remember that AX to AB, this is a ratio. So for vector AX is given. Vector AX is 2. Okay? Vector AB is 3. Okay? So vector AB is 3. So vector AX, it is 2. So here it is 2. That is vector AX. So that is AX. Then AB, it is 3. Okay? It is 3. So now what about XB? So XB, we can just subtract. AB minus AX, AB minus AX, we are going to have XB. So AB, it is 3. AX, it is 2. So the answer is 1. So XB, it is 1. So 2 plus 1, it is 3. So which is AB. So AB, it is what? 3. I hope you are following on that one. So AB, it is 3. So AB, it is 3. So which is 2 plus 1, 3. So find XB. So our XB, the ratio for XB is 1. Okay, so I'll say XB. So here we are not going to move triangular. Instead, we are going to use the ratios to find XB. So XB is 1. So I'll say 1 over the total ratio, which is 3. 2 plus 1, which is 3. So over 3 times vector A, B. Vector A, B. So of which vector AB we have, it is this one. So I'll just substitute. So vector XB is equal to 1 over 3. Vector AB, it is scalar B minus scalar A. So this is our answer. So express in terms of scalar A and or scalar B, X, O. So vector X XO. So XO, so in this case, I'll move triangular. XO is equal to XB. Do I have XB? Yes, I have. Okay. BO. So I will use this root. If I want, I can use this root. The answer will be just the same. So now to simplify things, I already have XB. So XO is equal to XB plus BO. So vector XB we have. So this is vector XB. So from here now, I'm going to expand vector XB. I'll expand. So 1 over 3 times scalar B, it is 1 over 3 scalar B, 1 over 3 scalar A, it is 1 over 3 scalar A. So this is XB plus vector BO. So BO, I'm going against the direction of the vector. So it is going to be negative scalar B. Okay? It is going to be negative scalar B. So that is the negative. So negative scalar B. So why is it negative scalar B? The reason why it is negative scalar B is we are going against the direction. The direction is OB. Now we are going BO. So it's going to be negative. So from here now, I am going to collect the like terms. I'm going to collect the like terms. So the like terms are 1 over 3 scalar B and scalar B. These are like terms. So I'll say 1 over 3 scalar B minus scalar B. Okay? Minus 1 over 3 scalar A. So this is the negative scalar B. So this is the one. It is not going to change the sign because it is not crossing the equal sign. So from here now, this is a fraction. We can express this one to be a fraction by saying over 1. So from here, you look out for the lowest common denominator of 3 and 1, which is 3. So 3 into 3, it is 1. So 1 times scalar B, it is scalar B. So 1 into 3, it is 3. 3 times scalar B, it is negative 3 scalar B minus 1 over 3 scalar A. So from there, I'll say scalar B minus 3 scalar B, it is, in other words, here it is 1. Okay? In other words, here it is 1. The coefficient of scalar B is 1. So scalar B minus 3 scalar B, it is negative 2 scalar B over 3 minus 1 over 3 scalar A. So this is the answer. Part 2, given also that vector OY is equal to 3 OX, show that vector BY is equal to scalar A plus scalar B. So how do we show that vector by is equal to scalar A plus scalar B? So the first thing that you have to do, you have to make a formula for by. Iri ayine batwebeera okukita show eyo twala apangirako formula echa number 1. So apa formula twala apanga ya by. That is the formula that we are going to make. It is for by. So don't pay attention to OY. So make the formula for by because it's the one that we've been asked to show. We are showing by. So you make the formula for by. Vector by is equal to, so we are going to make the formula for by. We are going to move triangular. So vector by is equal to, do we have vector BA? Yes, we have, which is AB. Do we have AY? We don't have. Now, by is equal to, do we have bo? Yes, we have. Do we have oy? Yes, we have oy, which is in this one. So by is equal to bo plus c o y. So vector bo, it is negative. It is going to be negative. It's going to be negative scalar b. Okay, we are going against the direction, so it's going to be negative. Now, do we have vector oy? So oy, we have been given the formula for oy. So we are going to find oy using this formula. The formula is already given here. So let me find vector oy. So vector oy is equal to 3 x. That's a formula. So vector oy is equal to 3 times, do we have vector ox? So do we have vector ox? As far as I know, we have vector xo, which is this answer. Okay, but remember here is ox and this is xo. So that simply means that for me to have ox, I'll just put a negative on xo. Okay. So it is going to be negative xo, it is negative 2/3 scalar b minus 1/3 scalar a. So that's what we have. So from there, I'm going to break the brackets, negative, negative. That is positive 2/3 scalar b, negative, negative. That is positive 1/3 scalar a. So now, so I remain with 2 scalar b plus scalar a. That's what I remain with. So this is my OY. This is my OY. Remember that the common denominator there, it is 3. And we are multiplying with this 3. So there, 3 and this 3 goes. So we remain with 2 scalar b plus scalar a. So that is my OY. I'll substitute now. So it is plus 2 scalar b plus scalar a. So negative and positive, you subtract, these two are like terms. So this is 1. So 2 scalar b minus scalar b, the answer is scalar b plus a. So I've been asked to show that vector by is equal to scalar a plus scalar b. So remember that these two, they are associative. So that simply means that it is scalar a plus scalar b. So it is shown. So number 4, part A, solve the equation 7 minus 2x squared equals x, giving your answer correct to 2 decimal places. So this is the quadratic equation. So this is the quadratic equation. When we are solving the quadratic equation, we need to use the quadratic formula. So now, how do we know that this is the quadratic equation? The highest power is 2. So that is the quadratic. So the quadratic equation formula, it goes by x equals, okay. So the equation is 7 minus 2x squared equals x. So that is the equation. So remember the order. Remember the order of the equation. So the order of the equation, it is a x to the power 2 plus bx plus C. So that is the order of equation, where we start with the highest power followed by the lower power and the lowest power. In other words, this is x to the power 2, x to the power 1, x to the power 0. So the order must be in that fashion. So we are going to rearrange this equation. So this equation must be rearranged. So how do we rearrange? So it is going to be, this is negative 2. It will go this side. It is going to be positive 2x. Okay, then this is positive 7. When it goes this side, it is going to be negative 7. So ukuk side kwarashala 0. So 0 equals positive 2x squared plus x, this x, minus, this was positive 7. When it comes here, it will be negative 7. So now this equation, it is the same as 2x squared plus x minus 7 equal to 0. It is the same. So now let's go to the formula. So this is the formula. So we need the value of A, the value of B, the value of C. So the order, remember that is the order. So we have ax squared plus bx plus c. So in this case, the coefficient of x to the coefficient of x to the power 2, that is the value for a. So x to the power 2, its coefficient is 2. So the value for a, is 2. Okay. Then the coefficient of x, that is b, the coefficient of x, that is 1. So there is 1. So the coefficient of b is 1. Then c is negative 7. C is equal to negative 7. So from there now, I'm going to substitute in the equation. Where there is a, I'll substitute 2. Where there is b, 1. Where there is c, negative 7. So it's going to be x equals negative, where there is b, 1, plus or minus square root, where there is b, we substitute 1, so it will be 1 squared minus 4 times, where there is a, 2, where there is c, negative 7, over 2, where there is a, we substitute 2. We simplify further, x equals negative times 1, that is negative 1, plus or minus the square root of 1 squared, it is 1. So this is negative 4 times 2, that is negative 8. Negative 8 times negative 7. So negative times negative, that is positive. So it will be positive 8 times 7. So the answer is 56. Divided by 2 times 2, that is 4. So x equals negative 1 plus or minus. So 1 plus 56, that is 57, divided by 4. So from there, we are going to find the square root of 57. So x is equal to negative 1 plus or minus the square root of 57 to 2 decimal places is 7.55 over 4. So this plus or minus, it means that here we are going to make 2 equations. We're going to make 2 equations. So equation 1, it is going to be x equals negative 1 plus 7.55 over 4, or negative 1 minus 7 6.55 over 4. So x equals -1 plus 7.55. We're going to have 6.55 over 4, or -1 minus 7.55. The answer is -8.55 over 4. So x equals 4 into 6.55. The answer is 1.6. Remember, it is to 2 decimal places. So 1.64, or 4 into -8.55. The answer is -2.1. So that is your 5 marks. So make sure that you show every step for you to earn all the marks. So part B, given that matrix B is 4, -1, x, -3x. So find the value of x for which the determinant of B is 22. So there the determinant is given, which is 22, and that is a 2 by 2 matrix. So in other words, indirectly, they are telling us to say, can you use the formula for determinant to find the value of x? So formula ya determinant eyo twala abomfya. So now if you have been given a matrix A, B, C, D, so how do you find the determinant? We call this as the major diagonal, and we call this as the minor diagonal. This is a minor diagonal. So how do you find the determinant? So determinant is equal to major diagonal minus minor diagonal. So now the major diagonal is A and D. So it will be A times D, minus minor diagonal, it is B times C. So that is the formula that we are going to use. So remember, you need to start with a major diagonal minus the minor diagonal. Should you make a mistake, the answer will be what? Wrong. So part 1. So now the matrix given, it is 4, -1, x, -3. So this is the major diagonal. So this is the major diagonal. So the major diagonal is 4 times -3x minus minor diagonal, it is -1 times x. -1 times x equals, the determinant is 22. So equals 22. So 4 times -3x, it is -12x. Okay? So minus this minus -1 times x, it is -x equals 22. So negative, that is positive. So -12x plus x equals 22. So -12x plus x, the answer is -11x. So remember, this is paper 2. You'll be required to use a calculator. So if you are not sure, -12 plus 1, just go on the calculator, -12 plus 1, then it will give you -11. So equals 22. So we divide both sides with -11, -11, -11, -11 goes. X is equal to -11 into 22. It is -2. So that is the value of x. Part 2. Hence find the inverse of B. So we have now matrix B, which is 4, -1. Where there is x, we are going to substitute -2. Remember that the value of x is negative 2. So where there is x here, we substitute negative 2. So where there is x here, we substitute negative 2. So it's going to be negative 3 times negative 2. So it is going to be positive 6. Okay? So negative 3x, so it is negative 3 times negative 2, which is positive what? So how do we find the inverse of the matrix? So inverse of the matrix, it is given by this simple formula. So inverse of matrix B is equal to 1 divided by the determinant of matrix B times the adjoint. So now, do we have the determinant? Yes, the determinant of the matrix is given to be 22. So the inverse is equal to 1 over 22 times the adjoint. So how do we find the adjoint of matrix B? So to find the adjoint of matrix B, you need to swap the major diagonal. You need to swap the major diagonal. So 6 yala hapa 4. 4 yala is hapa 6. So you need to swap. So 6, then 4 comes there. That is what we are going to do with the major diagonal. Then the minor diagonal, the signs will change. If this is the negative 2, it will be positive 2. If this is the negative 1, it will be positive 1. So this is the adjoint. So 1 over determinant times the adjoint. Number 5, evaluate. So we call this as definite integrals. So where we have the upper limit, we have the lower limit. So the first thing that we need to do, we need to integrate this one. Remember, when you are integrating a x to the power 1 dx, so you are integrating with respect to x. So what we are going to do is we are going to add a 1 to the power of x. Okay, so it is going to be a x to the power n. So we are integrating with respect to x. So kuli power twala addingako 1. You divide with the same power, which is n plus 1. That's what it means to integrate. In this case, with respect to x. So we are going to use the same formula to integrate this one. So there we are going to say kuli power ya x twala addingako 1. So it will be 6x 5 plus 1 divided by the same power. So in this case it is 5 plus 1 minus x. So kuli power to adding a 1 divided by the same power 4 plus 1 plus 3x to the power 2 plus 1 divided by 2 plus 1 minus this is 1. So there you introduce x to the power 0. That x to the power 0 is 1. So this one, it is x to the power 0. So we say plus 1 over 0 plus 1. Then the upper limit is 2. The lower limit is negative 1. So there we say 6x 5 plus 1, 6 over 6, minus x 4 plus 1, it is 5 over 5, plus 3x 2 plus 1, it is 3 over 3, minus x 0 plus 1, it's 1 over 1, 2, negative 1. So 6 and 6 goes, so we remain with x to the power 6 minus. So where there is x, we substitute 2. So it will be 2 to the power 3. Where there is x, we substitute 2. So this is for the upper limit minus. Again, where there is x, we substitute the lower limit, which is negative 1. So negative 1 to the power 6 minus, where there is x, we substitute negative 1 to the power 5 over 5 plus, where there is x, negative 1 to the power 3 minus, where there is x, negative 1. So from there, 2 to the power 6, we have 64 minus 2 to the power 5, that is 32. 2 to the power 3, that is 8, minus 2 minus negative 1 to the power 6, it is positive 1. Negative 1 to the power 5, it is negative 1, plus negative 1 to the power 3, it is negative 1. So negative times negative, that is a positive. 64 plus 8, 72. 72 minus 2, it is 70. So 70 minus 32 divided by 5 minus negative, that is positive. Negative 1 plus 1, that is a 0. Negative 1 plus 1, it is a 0. So negative, it is positive. Negative times negative, it is positive. So positive 1 over 5. So from there, you can just use a calculator to say 70 minus 32 over 5. The answer is 318 divided by 5 minus 1 plus 1 over 5. The answer is 6 over 5. So the denominators are the same. I'll just go direct and subtract 318 minus 6. We're going to have 312. So there, that is the answer, or 62.4. Part B. The flow chart below shows the steps that are carried out in calculating and displaying the area of a sector given its radius r and angle of the sector theta. The question is, write a pseudocode corresponding to the flowchart program above. So how do we write pseudocode? To start, so when you're writing the pseudocode, so you say you start, so start, then the second thing, enter r and theta. So now you are going to write the word enter just from here. Enter radius and theta. Okay, that's how we write the pseudocode. You don't need to write in the same line, no. Okay, so start, enter radius and theta. Now we are on this stage. Is r less than 0? That's the question. If it is a yes, print error, r is not valid. So is going to change to if. So you say if r is less than 0, If indeed R is less than 0, if it is a yes, print error R is not valid. So you say then, if it is a yes, you say then print error R is not valid. So if it is not true that R is less than 0, you need to proceed. So you need to proceed by saying else A is equal to theta over 360, okay, times theta times R to the power 2. And there you say and if print A, you do what? You stop the program. So stop, it must be in the same line with the start. You stop the program. So that is your 5 marks. So number 6, part A, the first 3 terms of a geometric progression are 3w minus 2. That's the first one. Second one is 3w plus 6. And the third one is 3w plus 30. So find the value of w. So we have the first term 3w minus 2, 3w plus 6, 3w plus 30. So this is the first term. This is the second term. This is the third term. So the first question is find the value of w. So how do we find the value of w? So for us to find the value of w, we need to use the formula for calculating the common ratio. You use the consecutive terms, and these are consecutive terms. Second term divided by the first term. It is the same as you say third term divided by second term. So that's how we can calculate the common ratio. So now this is the formula that we are going to use to calculate the value of W. So of which we have been given the second term is 3W plus 6 divided by the first term, which is 3W minus 2, equals third term is 3W plus 30 divided by second term is 3W plus 6. So that is what we are going to do. So from there, we cross multiply. So 3W plus 6 times 3W plus 6. So 3W plus 6 times 3W plus 6 equals 3W plus 30 times 3W minus 2. So 3W plus 30 times 3W minus 2. So from there, we expand. We expand 3W times 3W, 3W times 6. So 3W times 3W, that is 9W squared. 3W times 6, that is 18W. Again, 6 times 3W, it is 18W. 6 times 6, that is 36, equals. Then you say 3w times 3w, that is 9w squared. 3w times negative 2, we have negative 6w. 30 times 3w, that is 90w. 30 times negative 2, that is negative 60. So from there, we are going to correct the like terms. We are going to correct the like terms. So if fyonse w tufike kumo, if tafike w tufike kumona fiena. So we have 9w squared. This 9w squared, it will come this side, it was positive. When it comes this side, it will be negative 9w squared. So this is 18w plus 18w. We're going to have positive 36w. So negative 6w plus 90w, we're going to have positive 84w. So this is positive 84w. Where is it coming from? Negative 6w plus 90w. We are going to have positive 84w. So it was positive. When it comes this side, it will be negative 84w equals, this is negative 60. This is positive 36. When it goes this side, it will be negative 36. So 9w squared minus 9w squared, it is 0. So this is a 0. 36w minus 84w, we're going to have negative 48w equals negative negative you add, we're going to have negative 96. So from there, you divide throughout with a negative 48 over negative 48. So this one and this one goes. So we have w is equal to negative negative, it is positive. 48 into 96, it is 2. So second question, find the nth term. So find the nth term. So for us to find the nth term, we say nth term is equal to a r n minus 1. So nth term is equal to, do we have a, which is the first term? So the first term we have, it is 3w minus 2. So we have the value of w. So the value for w is 2. So where there is w, we are going to put a 2 minus 2. So 3 times 2, 6. 6 minus 2, we are going to have 4. The first term is 4. So this is the first term. So 4 times r, it is simply the common ratio. So remember that common ratio is equal to second term divided by the first term. We have the value for the first term, which is 4. Let's look at the second term. Second term is equal to, so second term is 3w plus 6. So 3w, the value for w is 2. Okay, plus 6. So 3 times 2, that is 6. 6 plus 6, that is 12. So common ratio is equal to second term is 12, first term is 4. So r is equal to 4 into 12 is 3. So common ratio is 3. So 3 to the power n minus 1. So that is the answer. So or if you want, you can say nth term is equal to 4 times 3 n minus 1. It's the same. So the mistake that you can make, it is to multiply 4 times 3. So there you can't multiply because of this power. So don't make a mistake to multiply these two because of the power here. You can't multiply that one. So there are two formulas. Sum of the n terms is equal to a r to the power n minus 1 over r minus 1. There's another one. Here it is 1 minus r to the power n over 1 minus r. So now, when do we use this formula? So we use this formula if the value for r is greater than 1. Okay? When do we use this formula? We use this formula when the value for r is less than 1. So let's look at the value for r. The value for r is greater than 1. The value for r is greater than 1. So the formula that we are going to use is this one, not this one. Okay? So we're going to say sum of the first 4 terms. Sum of the first 4. Where there is n, we put 4. So n is the number of terms. Okay? So how many terms? Sum of the first 4. So the value for n is 4. A, it is 4. R, it is 3. N, it is 4 minus 1 over 3 minus 1. So there, sum of the first 4 terms is equal to 4, 3 to the power 4. It means 3 times 3 times 3 times 3, which is 81, minus 1 over 3 minus 1, that is 2. So sum of the first 4 terms is equal to 2 into 2, 1. 2 into 4, it is 2. So it will be 2, 81 minus 1, we are going to have 80. So sum of the first 4 terms is equal to 2 times 80, we are going to have 160. B. So 10a divided by m squared n to the power 2 divided by 5a to the power 3 divided by 2m squared n squared. So from there, the first thing that we need to do, we need to change this division. It must be changed to multiplication. So you say 10a over m squared n squared times. So when this division changes to multiplication, then this fraction, it will change. The denominator will be the numerator. The numerator will be the denominator. So we are going to have 2m squared n squared over 5a to the power 3. So from there, I'll simplify by saying 10a, it is 10 times a, over m squared, it is m times m times n times n, that is n squared, times 2 times m times m times n times n over 5 times a times a times a. So from there, so hapa twalakansa efupalene. So efupalene a na a twakansa. So a into a1, a into a1, m into m1, m into m1, m into m1, m into m1, n into n1, n into n1, n into n1, n into n1. So 5 into 5, 1. 5 into 10, 2. So there is nothing more now. We just have to multiply. So 2 times 1 times 2, that is 4. 4 times 1 times 1 times 1 times 1. So we are going to have 4 divided by 1 times 1 times 1 times 1 times 1 times 1 times a, which is a squared. That is the final answer.